Hi, welcome to another mini lecture on pre-calculus, and these two sections are actually prerequisites for pre-calculus. So we are going to quickly go over these two set of problems that are getting you ready for logarithm. So logarithm is a way to study exponentiation. So if we have a to power of b is equal to c, we have a cast of three numbers in this equation. Sometimes we want to find c, sometimes we want to find a, sometimes we want to find b, and this leads to, well, three different problems. First problem is straightforward exponentiation with fractional exponents. So here is referred to as a rational exponent. So rational exponent with unit fraction, it means 1 divided by a number, that's a unit fraction. Non-unit fraction means, well, numerator of this fraction is something other than 1. So these two sets of exercises are essentially getting you ready for logarithm, and the textbook essentially expects you to answer from memory. Let's just go ahead and take a simple example. Suppose I have 2 to the power of 3, which you know is just 8. Now suppose you have 3 and 8 given to you, and then you want to find this number. So out of these two, how do you extract 2? Well, the way we write this thing is 8 to power of 1/3 is 2. Another way of expressing the same thing is that cube root of 8 is 2. So this is the view we are taking right now. If I have a number raised to a unit fraction, how do you find the answer? Essentially from memory, and just remember that 8 to power of 1/3 is another way of saying cube root of 8. Okay, how do we remember these things? For example, 2 to the 216 to power of 1/3. So we have to go through on memory. What number was it that when it was cubed, it gave us 216? Here, what's a number that if it is raised to power of 4, it's going to give us 16, and so on. So let's go ahead and take a look at, so if I have 216 to power of 1/3, and I want to know what that is, that's another way of saying, well, what number is it? So I cube both sides, it becomes x cubed. Cubing this gives us power of 1 is 216. So we are trying to find answer to this equation, and from memory when we say the answer is 6. The other one is what was it, 16 to power of 1/4. Suppose we want to solve that. Well, so I don't know what the answer is. Whatever that answer is, that answer raised to power of 4 has to be 16. And all over here, when the exponent is even, we are after the positive root. So this has another negative root as well, but the answer we are after is, well, what number is it that is positive, and when it is raised to power of 4 gives us 16? Well, that is 2. Well, how do we know? Essentially, as we said, by memory. So what the textbook and most of upcoming math classes expect from you is to know various powers up to say 1,000 or 2,000 or something like that. So let's just go ahead and practice. Of course, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 3 is 8, 4 is 16. What is 5? Well, 32. 664, and then 2 to the power of 7 is 128, 2 to the power of 8 256, to the power of 9 512, to the power of 10 1024, to the power of say 11 2048, to the power of 12 4096. You notice these numbers are familiar to you when you buy any kind of computer equipment, various capacities, if it is megabyte, gigabytes, or terabytes, or whatever it is. These are the numbers that are associated with it. This is what is in computer industry is referred to as a kilo, and 2 to the power of 20, well, we are not going to memorize that, but that's what is referred to as a meg, and to the power of 30 is a gig, and so on. Okay, this is what we need to memorize for power of 2. So for example, if I ask what is 256 to power of 1/8, that's just this problem. The answer is 2. If I ask what is 1024 to power of 1/10, what's a number that when it's raised to the power of 10 gives us 1024? Well, that's again 2, and so on. Same thing we need to memorize for 3. 3, of course, to power of 1 is 3. 3 to power of 2 is 9. 3 is 27. 4 is 81. 5 is what, 243. 6 is 729. And then after that we are going to hit 1000 category. Okay, what else? So let's do an exercise here as well. What is 81 raised to power of 1/4? The answer is 3. What is 243 to power of 1/5? We are capturing this equation. That's again the answer is 3. 4 to power of 1, 4 to power of 2, 4 to power of 3, 4 to power of 4, and so on. You can make the list. You might be asking, well, I can do this thing on my calculator. Why do I have to memorize? For learning mathematics, you need to be quick on your feet to follow a conversation. If every time one of these things comes up, you want to take out the calculator, press some buttons, and make sure that you are actually pressing it correctly, and so on, you kind of lose the flow of the conversation. It would be like listening to a joke through a dictionary, looking up word by word and trying to figure out what the joke meant. Same way here, you need to actually have these numbers in your mind, available at the tip of your finger, and then things are going to work a lot better. Let's go look at 5. So 5 squared is 25, cube is 125, power of 4 is 625, the power of 5 is going to be 3125, and so on we go. How about 6? 6 to power of 1, 6 to power of 2, 6 to power of 3. That's what was there in the exercise. 6 to power of 4, that's going to be 1096. How about 7? 7 to power of 2 is 49. That much you remember from elementary school. Now you are expected to go one notch higher. So 343. 8 8 to the power of 3 will be the same as what, 2 to the power of 9, that's 512, and so on. 9. So at least we need to know up to 1000. Of course, the easiest one is for 10, because you just increase number of zeros. Okay, so that's easy. 11 sometimes comes up. Excuse me. 11 squared is 121. 11 cubed is 1331. 11 to the power of 4 is 14641. There's a pattern to these numbers. I hope you see that from Pascal triangle, and so on. So these are a set of powers that we need to know by memory. It's recommended we know them by memory, just so that the conversation flows easier. Next up, what if my exponent was a fraction and the numerator of it was something other than 1? Well, let's do that. 32 to the power of 2/5. How do we understand this? 32 to the power of 1/5 to the power of 2. So we find the fifth root of 32, which is 2, and take that and square it, and then I get 4. Okay, so if I have 216 to the power of 4/3, understand by that 216 to the power of a third, cube root of 216 to the power of 4. So that's going to be, again, this one we learned from memory, 6 to the power of 4, and 6 to the power of 4, we go ahead and find it, whatever it is, or we just leave it as it is, 1296. This is actually preferred, but if a simplified answer is required, that's what we find there. Okay, so what was the issue? We are getting ready to understand various ways of looking at this equation, a to the power of b equal to c. So if we want to rewrite that, so if I have a to the power of b is equal to c, one way of writing this thing is to say c to the power of 1 over b is equal to a. Everybody sees that? If I raise both sides to the power of 1 over b, this is what it says. So again, if I have 2 to the power of 3 is equal to 8, that's same as saying 8 to the power of 1/3 is 2. Now, what we are after here is, what if we are extracting b? So another way of writing this is a to the power of b is equal to c. Another way of writing that is logarithm of c in base a is b. For example, if I have 2 to the power of 3 is equal to 8, I can say logarithm of 8 in base 2 is the number 3. So the conversation above is a way to get ready for logarithm, which we are going to restart on the next lecture. Until that time, good luck and God bless.